years of high-speed flows with special interest in electrothermal and biomedical research. Karthik has the perfect combination of an experienced researcher, a successful academician, and an emerging technology strategist. He now works as the technical manager Indo-Pacific at Hexagon. May I request him to come up on the dais and start the session?
So good afternoon, everyone. So first of all, thanks to everybody who is here today attending this session. I'll try to keep it as informative and quick as possible. Reintroducing myself, I am Karthik Sundarraj. I handle the technical management as well as the advisory activities of electronics industry for the company Hexagon. And today what I'll be talking about is how can we really digitally transform electronic industry. Of course, everybody is aware of manufacturing and so on, but we as a technology provider, how are we really helping our customers and everyone to digitally transform almost all the phases of electronic manufacturing, electronic design, and even the quality to that matter. Now, just looking into some of the research activities that has gone into the assessment. Thank you. So, of course, there's overwhelming evidence that digitization helps to improve business efficiency and margin. These are already existing cases that you can always look into. So, the evidence is not just theoretical. Okay, so companies who have adopted some degree of digitization are moving ahead, and this is not restricted to digitally native companies who started out of digital world. This is increasingly traditional companies. Okay, so what's interesting is that we can see that whoever is leading in this particular digitization and digital transformation, they are majorly high-tech companies, telecommunication companies, the IT sector companies, and so on. Now, so what do we get to learn from them is that digitization moving ahead is very critical, not only for the assessment of the technology, but let us say you want to do a new product introduction into the market. So how can you really digitally understand your new product introduction? So I think most of us are already aware of what is happening in India from the electronics perspective. I don't have to re-emphasize on these points. So one is the PLI. I think everybody is aware of PLI, the need for PLI, necessity for PLI, and how other electronic landscapes are for the country like us. And we are also aware what sort of consumer market we are in. Okay, why I am talking about all this is now this is a country, or you are in a position where there is huge amount of requirement when it comes to electronics, and I think pretty much none of us can deny the fact that we are heavily dependent on the electronics market, right? So now what I'm proposing is that we need to embrace our own companies setting up their manufacturing units in India, with a lot of international companies coming into India to set up their own spaces. I think it's important to accelerate productivity. And one very important way to do that is digitization. I'm just connecting back to the topic that I'm presenting today. Then the resilience aspect. So we are heavily reliant on a lot of external technologies. So I think it's important for us to innovate, invest in this innovation, and then build resilience. So these are some important aspects that I would like to cover during this talk. And a quick video on what is Hexagon and why technology has been important. No, that's okay. It's okay. The video is typically demonstrating how, as a company, we are digitally able to connect to different aspects and different technologies in a simple example, like let us say in this case, it will be a microphone, or let us say a simple speaker. So how we as a technology, so what you see here is, now let us take a simple speaker. Now there are multiple elements involved in the design of the speaker. It could be the acoustics, it could be the structure, it could be the material that is used, it could be the wiring, the connectivity. I mean, a lot of aspects is involved. Gone are the days where there is no interconnectivity now. And these type of electronics now are installed in places like, let's say, automotive or aerospace equipments. Now, again, the complexity keeps building and the integration factor becomes more and more critical. So I'm sorry about the video. As usual, the technical glitches will continue. So however advanced we are, right? So quickly introducing to Hexagon. So Hexagon is a 25 billion market cap company. It is present in almost all the technology areas. So you can see maybe agriculture or building or electronics or automotive, aerospace and so on. And we are located in about 50 countries across the world. And what is our key strength? The core area is autonomy. So we are a company who is continuously working towards autonomy, and through three core competence areas. One is the sensor technology. Okay, so this is our one of the core area, that is ability to capture data and ability to integrate sensors into all possible equipment. Reality capture. So we have our own cameras, we have our own 3D scanners, we have our own equipment, CT scanning systems to have reality capture, and we are also capable of positioning, that is geosystems and georeferencing. So this being one of our core competence. The second important competence is autonomous solution. Okay, so a quick example is we are partnered with Lexus and we manufacture about 40 autonomous car every month. So we are into one of the core competency for us is autonomy. And the third most important is digital. So what we call as software. I mean, I'm not happy to put this word software solution because now it's more about digitization. And of course, with the help of software, we do a lot of digitization. Okay, so these are the three important core competencies. And out of this, we are going into smart digital reality. Okay, so we use our core competencies to typically have digital accessibility, infinite connection, and autonomy. So out of all these, we eventually plan to reach smart digital reality. A quick understanding of where we are positioned. So about 95% of the cars produced, 90% of the aircraft produced, and 85% of the smartphones that are produced, there is Hexagon technology everywhere. So all of them are major users of Hexagon technology. And so for us, it is very easy and important to be that people who are part of your digital transformation. So that is one of the core, the areas that we think of implementing to as many customers as we can touch. So moving ahead, I think connected and automation process. So we have created this data island to drive that particular value. So while we have a number of solutions, our goal is always connected to our capabilities. So it's not that we go outside our capabilities to ensure something that is not possible. And one such is, we have all these capabilities. So let us say, starting from design and engineering. So you have factory operation capabilities, manufacturing, quality, and service, right? So these are all the important areas which are necessary for any electronic end-to-end manufacturing that you can perform. And to further help on the smartness in the way you manufacture, right? What are the entities that is influencing this entire manufacturing aspect. So this is basically digital transformation. Your ability to connect your design to the production, your ability to connect production to inspection, your ability to do inspection and then maintain and then a feedback loop, right? So everything that is, as you design, as you manufacture, as you produce, and as you see the quality back to your CAD model. So everything has to be connected in this digital environment, and that is what we are trying to provide to most of the people who will use Hexagon. So we have divided this into a digital space and a physical space. So if you see here, there's a very fine line. Digital space, of course, performs all these activity in a digital environment, or in other words, software environment, whereas the physical space definitely uses, let's say, a scanner, a CMM machine, or a quality sensor, and so on, right? So all these digital and physical space have to be interconnected, and that is one of the most unique aspect of Hexagon as a smart manufacturing provider. Okay, now looking at electronics, typically why an electronic equipment fails. I think this is the most critical aspect that any electronic manufacturer has to look into. So the four major reasons why they fail is temperature. I think everyone agrees to this. Any increase in temperature leads to failure. Humidity and moisture. Okay, we have a lot of customers working on addressing humidity and moisture aspects because all the electronics are now compact. They are completely closed. There is no space for air to move. There is no space to airflow to happen. So natural convection becomes very low now. And you are fully reliant on evaporation and condensation aspects. Then vibration and shock, drop testing. If you drop a product, how durable is it? If you drop a product, will it break or not? I think we all agree, our older mobile phones, how much ever we used to drop and play around with it, never used to break, right? Now with advancement in technology, we are seeing a lot of issues in this space, purely because there is no way for the force to escape a particular body now. So earlier days, you might have seen the mobile phone used to break up into multiple pieces. So your battery will come out, your front panel will come out, your back panel will come out. So that is one of the ways the energy is going out of your equipment. But now all your mobile phones are completely sealed. So there is no way energy can go out of your component, and so it breaks your screen, which is the easiest part from where your energy can come out. So these aspects. And of course, contaminants and dust. Now this is important from the IPX certification. I think everybody wants to have a watertight, dust-tight sort of equipments, and these play a major role in failing the product. Apart from that, what are the products that are typically failing because of these aspects? So just a look at that. And then what is it that is important when there is a new product introduction that is happening into the market, right? So I think most of us are aware that only 3% of the consumer electronic startups make to the market itself, successfully. Okay, and why that is happening is because there is product launch issues, there is product technical issues, there is manufacturability issues, availability of technology issues, and so on. So there's a lot of factor integrated into this inability to launch a particular product, and that is where digital transformation comes into picture. So if you want to really launch a product, can you perform digitally a design? Can you produce your product digitally first? Can you see the feasibility of your product in a digital manner? And can you see the maintenance aspect of your product in a digital manner before even going into the launch or the product development or the design and prototyping phase? Okay, to help that, let us see what do I mean by a digital thread. Okay, now you are seeing an example of a simple joystick. You can imagine this joystick to be any other electronic equipment. And when I am talking about design and engineering, I am talking about materials modeling. I think all of us want lightweight materials. We don't want a heavy metal phone or anything of that sort. So you have to start by designing your material, the right material, then manage your material. So some of the OEMs may manufacture and make their own material, and these will be proprietary materials, right? Now, how do you manage your material? That is also digitally you have to maintain. Designing your component, thermal management, and structural integrity. Some of them include motion, right? Your electronic components may have a lot of moving equipments. How do you understand the dynamics of your product? Frequency in terms of structural frequency, acoustic frequency, so on. Fatigue, impact, like your drop testing. Plastic flow, so your molding activities, right? How do you ensure accuracy in molding? Internal scanning. So if I want to understand whether all my parts are integrated well into the equipment, what is the one thing that anybody does is CT scan. So you put your equipment to a CT scan, but that is a high investment technology. So you need a digital technology to basically understand this structure before even investing in a CT scan machine, right? So digitally, can you do this particular internal scanning activities? And then of course, the process qualification. So are you going through the right process to design the right material? So this is from the design and engineering perspective. Then comes your manufacturing and production digital thread. So whatever you see here is a digital thread. None of them are using any machines. They are all using a digital ecosystem, right? So digitally, can we do additive manufacturing? I think mobile, any electronic uses additive. Digitally, can we do metal studies like sheet metal stamping, forging, forming, welding, whatever it is? And robotics, heavily dependent, but can we digitally do an assembly line and do that entire process? Tooling, what sort of tooling is needed? What sort of CAM activities are required? Everything, including your asset management and production execution, everything in the digital ecospace. Right? Now, this being your manufacturability and production capability studies, then comes your quality and validation studies. And can we do this phase also digitally, like inspection, non-destructive testing, laser probing, dimensional accuracy validation, positional alignment, thickness, coplanarity, flatness of your product, let's say the screen or your PCB boards or your electronic component, homogeneity and real-time asset visibility, right? What is your asset you are having in the manufacturing phase? What is the current stage of production and so on? So everything becomes a digital ecosystem when you are able to connect them between the physical world and your digital world. So that is the solution we are talking about. And for that, I'm just going to take the same example of a controller because I cannot really show any of my customer product over here. So I'm taking a simple example of a controller and showing you how we are performing this, all the activities which I spoke to you in the form of digital thread. So the important thing is, let me start with design and engineering. So what you see here is, this is the digital 3D created CAD of a controller. We are performing structural analysis, thermal analysis, right? You can see the temperature contours, the motion dynamics. These are all your 6DOF motion equipments digitally recreated. And then the materials, the acoustics, what is the sound that is produced by this particular equipment, and so on. So this is from the design space, just taking a few sample cases there. And then manufacturing operations. So this is the mold flow. So you can see the flow of mold that is happening, right? Can we perform? So this is again entirely performed digitally. What are we planning to get out of this? Thermal stresses, structural stresses, flow of the mold itself, whether it is the fluid is flowing correctly, whether it is covering all the spaces, how is the thickness of the mold and so on. Can we do this at a digital stage? Then tool design and machining. So you can see here, digitally designing the tool, what is required for the manufacturability of this equipment, and then performing the complete machining activity. So you change different tools to do different intricate machining. Okay, so again, the machining tool design aspects integrated into the digital ecosystem. Then moving ahead on external quality. So these are CMM machines of Hexagon. Now, how can you scan this part and digitally assess the quality? So we are doing an external scanning of this and then taking the output of this digital scan to really understand the external quality of the surface, internal structure of this. Now, like I mentioned, your product, if you want to understand the IPX, these type of scan will help you understand where are the spaces through which water can enter, dust can enter, and can you re-simulate that and try to negotiate that flow of water to some other place and rather going to the PCB directly and affecting that. Then comes your quality inspection. So these are called as blue light scanners, white light scanners, laser scanners. So what we are seeing here is a PCB that is located inside the same controller. So with this, we are trying to do the quality inspection, transfer this data again digitally to understand coplanarity issues, structural issues, and so on. And detailed part measurement. So this is a digital environment which is recreated by the sensor probing. So you try to understand whether the measurements are as per your CAD. So this is the complete cycle you want to do, right? So whatever your designer made and what you manufactured, is it the same? Or is it completely different? Or is it not aligning to some of the aspects? So those type of part measurement activities, these are continued part measurement at the solder level or drill hole level. So this is more towards the nano and the detailed understanding of these solder joints, the hole joints, or the, let's say, thermal drill holes and so on. So how can you really scan and understand those aspects? And then finally, the material structure. Now this is a mobile phone which has undergone the CT scan. Now when you do a CT scan, it's just an image. Now how do you create a 3D of that CT scan to understand the internal connectivity, the structure of your mobile phone, right? So this is using some of the solutions where you convert your CT scan into a 3D image, and then you are able to break it down to understand if there is a part missing, let us say. So you have a mobile phone, but at the end of the line, you identify that a part is missing. There's no way that you're going to rip apart. So it's easy to do a scan to understand what is missing. A screw is missing, simple things. I mean, we are not talking about solving major issues. First, let us try to solve simple things like what is missing. And yeah, so this is the detailing. So something as simple as a controller can be as complex as this. And if you are unable to fit them through, then whatever might be the product is a challenge. And what we need to understand is there is literally a huge gap between our theoretical understanding and what practically happens. Okay, so theoretically, a structure may not break, but practically, for example, a phone of mine, it has been continuously falling for many days and it never broke. But one fine day, it just fell from a few feet from the surface and it broke. So that cannot be really theoretically validated. Okay, these are all understanding of material and experimental analysis. So to help, we also have worked with a lot of customers like Yamaha, let's say, or Bose or Panasonic to understand and develop these type of end-to-end technology. Okay, these are also available for many of you to have a look into it. And some of our customers, I'll just skip through this. And because of time, I'll I'll quickly finish this. So we are now venturing into solutions for 5G and automotive and aerospace. And we have this concept of OneMi, which is nothing but ability to connect design, production, inspection, and quality under one single platform. So that is what we call as OneMi. So with that, one important question is, how do you know that your technology and process will work? I think every new product manufacturer or every tech person who is going to introduce technology, this is the biggest question they need to understand beforehand. And to give you an answer to this is what Hexagon is basically going to help and thrive. Okay. With that, I end my talk. Thank you so much. If there is any question that anyone would want to ask, I'm happy to answer now.
May I request Sanjay, our mentor from Exhibitions India Group, sir, for you?